Let's learn an important concept in computer science, which is von Neumann architecture. Okay, if you have ever wondered how the computers process instructions, this is the key to understanding it. So, von Neumann architecture was proposed by John von Neumann somewhere around 1945. Okay, he introduced this idea of a computer with a single memory unit that stores both instruction and data. This design is still the foundation of most computers today. Let us try to understand the key components of von Neumann architecture. So there are mainly 5 components. The first one is memory. Second is control unit. Third one is arithmetic and logic unit. Fourth one is input and output devices. And fifth is registers. Now let's try to understand how everything will fit together. Now before we go into the details, let me say that this is called control unit and this is called ALU, and this usually we call it as IO devices. Okay. Let me show you an architect diagram. So what happens is in the von Neumann architecture, what you have is a box or a part which is the CPU, and then there is a part for memory. Okay. Within the CPU, you have control unit, you have arithmetic and logic unit. I'm just going to write this here, and then you have registers. Okay. Then you have input devices, and then you have output devices. It's as simple as that. Okay. Now let's understand each component. What is a CPU? Within the CPU is where we carry out computations on the data by following instructions. Okay, CPU is called the brain of the computer. Now within the CPU you have control unit, arithmetic and logic unit, and registers. Let's first look at control unit. So the control unit is like a manager of the CPU. It tells the computer how to execute the instruction by directing the flow of data between different components. It will tell, okay, pick the information from that area, put it here, etc. What ideally it does is it will fetch the information from memory, decode them, and then signals the CPU to execute it. Now comes the arithmetic and logic unit. The arithmetic and logic unit is for performing mathematical operations. What are mathematical operations? Addition, subtractions, or logical comparisons. Like logical comparisons means if you want to check one number is greater than the other, etc. Every calculation the computer does from a single max to a complex algorithm passes through the arithmetic and logic unit. Now where do control unit and arithmetic and logic unit take the information from? That is from memory. All the information is stored in the memory. So all the data and instructions are stored in the memory. The CPU take the information from the memory and then process it. So memory holds both the programs that are running and the data. So it contains programs plus data. Now, unlike a hard drive, this memory is temporary. When the computer is turned off, the data is lost. Okay. Now we learned 3 things: control unit, arithmetic and logic unit, and memory. Now comes the input-output devices. I'll just write it properly. Input-output devices. It is like keyboard or a mouse which will allow user to send data to the computer. Output devices are like a monitor or a printer. So I can write this as input devices. Examples are keyboard, mouse, etc., where we give information to the computer. Output devices are printers, monitors, etc., where we give information out of the devices. Okay, the CPU interact with the devices to ensure smooth communication between the user and the system. Now the last one remaining are registers. Registers are high-speed storage devices. High-speed storage areas that that reside within the CPUs. Why do we have registers? Because taking information from the memory is slow. So what we do is we take the information from the memory and keep it in the registers, and then the CPU can access it faster so that it can work on the current working process on a much faster manner. Okay, so for example, if the CPU is adding two numbers, those numbers and the result will be stored in the register for quick access. So this is how the concept of von Neumann architecture works. So let us go back to the picture and see whether it all makes sense. So you have a CPU here, which is the main component, and then you have the memory here, and there is a connection between the CPU and the memory. Okay, it automatically there's a connection, and this is done by the bus. Okay, CPU has a control unit, arithmetic and logic unit. It has a control unit, it's an arithmetic logic unit and registers. The control unit is like the manager. It tells the computer how to execute the instruction. Arithmetic and logic unit is for the mathematical operation. Registers are fast storage, fast access memories, and memory is where the instructions and the data are stored. And input and output devices are for sending information to the computer and taking information out of the computer. So this is the basic of von Neumann architecture. Just learn this off. There can be a question out of this. Pretty easy.